Hey guys, today we're going to take a look at some properties of vectors. So, let's see. So the first property we're going to look at is the commutative property of addition. So I have talked about this before, but what this is just that if I take vector A and I add vector B, that's the same as if I were to do it in the opposite order. Okay? So, in other words, the order of vectors is not important when adding. Okay. So, as an example here, if I were to take vector A, we'll call that vector A, and I'll add vector B. Okay. That results in vector A plus B. But you can see if I create vector B, so B is like that, and then A was like that, you can see that's going to create the same vector here. So this created vector, it's exactly the same. So it's B plus A this time, but it doesn't matter. It's exactly the same thing. Okay? All right, so the next property, the associative property of addition. Okay, so this is also fairly straightforward and may seem obvious, but these things are always worth specifically saying. So what this is that if I were to take three vectors, A, B, and C, and add them together, if I were to add A and B first and then add C, that's going to give me the same thing as if I were to add the B and the C first and then add the A. It doesn't matter, okay? So in other words, the actual order of addition of vectors is not important. So the order of addition, not just the order of vectors, but the order of the addition. Oops, there's an O in addition. Nope, that's not even close to how you spell addition. Addition, okay, the order of addition of vectors is not important. All right. So, to illustrate this, let's pop over here. If I were to take, so let's have vector A be like that. That's A. And then we'll have vector B be like this. And then we'll have vector C be like this. So you can see it's giving me this vector here. Okay, that's A plus B plus C. But you can see that it doesn't matter if I had done the A plus B like that and then added the C, I would still get this A plus B plus C. Okay. So I've done that with that one first, but if I do it again, okay, and these obviously aren't exactly the same, but you see it's close enough. If I were to add the B and the C first and create this vector, this would be B plus C, okay, and then add on the A, it gives me this same vector, okay, that's A plus B plus C, but this time I've added those two first. So it doesn't make a difference, okay? All right. So our next one, the distributive property of addition, and this is going to seem like you're doing grade 9 stuff again, and that's good. It should seem like that. But if I have, regardless, A and B are vectors like that, and I multiply them by a constant, K, or a scalar, I should say, that's going to be the same as if I did Ka plus Kb. Okay? So in words. This is where they get tricky to write in words, but so multiplying or a scalar by a sum of vectors is the same as adding the products of the scalar times each vector. Okay? So, in other words, or let's illustrate this here. So let's say I've got 2 times A plus B. Okay? So what that means is that I take A plus B, so there was A, and then there's B. That's A, and there's B, and that gives me A plus B. But I'm going to multiply that vector, the A plus B, I'm going to multiply it by 2, so I have another A plus B. Okay? So this resulting vector is 2A plus B. Okay? So if I were then to do it as 2A plus 2B, it would just look like this. We'd have A plus A, so that's a second A there, and then we have B plus B. Okay, and so the resulting vector is 2A plus 2B, which, although I didn't draw it perfectly, you can see is more or less the same vector. So it should be exactly the same vector. If I'd drawn it correctly, it would be exactly the same vector. Okay? All right, the next one is going to be hard to illustrate with an example, but the next one is one of the easier ones. So if I have any vector A and I add the 0 vector, it's still just A. Adding the 0 vector doesn't do anything. It's just like adding a 0 with our normal scalars, I guess. So adding the scalar, or adding the 0 vector has no effect. Adding 0 vector no effect. Okay, whoops. All right, I'm not pretty sure I spelled effect right there. I always get those two mixed up, but I'm pretty sure that's the right one. So to illustrate with an example, this is obviously going to be very challenging because if we've got vector A, and how do I show that I've added a 0 vector? I don't know. So it's still just A. Still like that. Nothing happening there. Anyway, yeah. Can't really draw the 0 vector, unfortunately, but okay. So next we've got the associative law for scalars. So what this is if I have M and I multiply it by N, which is being multiplied by vector A, that's the same as if I were to take the M and the N and multiply them and then multiply it by A, or conversely, you just have it as M and A. It doesn't make a difference, okay? So when multiplying, a vector by a product of scalars. The order of multiplication is not important. Okay. So we can illustrate this one with an example. So let's say I have 2 times 3a. Okay. So I'll draw a here. So let's say a just looks like this. I'm just going to draw a small one here. Okay, so that's a. So to draw 3a, it would be 3 of those. Okay. So we've created in blue 3a. So if I want to have 2 3a's, I would just add another one. So there's another 3a. And if you then look at this, that's creating this long vector like this, which is just 6a. Okay? Because you would have you'd have 1, 2, 3, 4, 5, 6. So there's just 6a's. Okay? So the order doesn't matter. I could create 3a and then multiply by 2, or I can just do 2 times 3 and find that it's 6, and then multiply that by a. Okay? All right, last one, the distributive law for scalars. Not to be confused with the distributive property of addition. So distributive law for scalars. So what this means is just that m plus n times a is equal to m times a. Whoops. M is not a scalar, or not a vector. So m times a plus n times a. Okay. So this one's fairly straightforward. It's going to be difficult to explain. So multiplying a vector by a sum is the same as by sum of scalars, I should have said. Of scalars. Is the same as multiplying each scalar. I am scalar by the vector and adding the results. Okay. Multiplying a vector by a sum of scalars is the same as multiplying each scalar by the vector and adding the results. Okay, so let's say that I've got 3 plus 2 times a. Okay, 3 plus 2 times a, or 5a. So this is going to be the same as having, if that's a, that's a, that's a, so that's a, which means this whole thing is 3a. Okay, and then I add 2 more a's, a. Okay, so that creates 2a. Then what I'm left with is just this whole thing, which is 5a. All right, and that's it. All right. So, until next time, go Sabres.